Every night, we lock our doors, draw the blinds, and go to sleep thinking we've successfully shut out the wild. But human homes are not sterile boxes. They are rich, active, ecological habitats, what biologists call the built environment microbiome. And the most active biological contact zone in your entire house is the place you spend a third of your life, your pillow and mattress. All day and night, we constantly shed tiny flakes of dead skin. A massive percentage of household dust is actually just us. The creatures moving through that dust are not invaders from the outside. They are native species, perfectly adapted to the biome we build for them every single night. In this ecosystem, the sleeping human body acts as the weather system. Over the course of a year, a typical adult releases up to 100 liters of sweat into their bed. Trapped under heavy blankets, that continuous release of body heat and vapor creates a microclimate, a perfect cultivation medium for invisible fungal networks. Typical used pillows host a massive diversity of these fungi, particularly a hardy species known as Aspergillus fumigatus. This bar chart compares the biodiversity and density of fungal colonies in different bedding materials. You can see how the column from modern synthetic materials completely dwarfs traditional feather pillows. Moving away from natural fibers did not sterilize our sleep. It actually provided these microscopic organisms with a vastly superior incubator. The apex consumer of this thriving ecosystem is the house dust mite. They are microscopic arachnids, distant relatives of spiders and scorpions. Despite their appearance, they are entirely harmless to living tissue. They are scavengers, not parasites. They don't bite, sting, or burrow into our bodies. Their sole food source is our discarded skin. Because dead skin cells are as tough to digest as hair or feathers, mites rely on incredibly potent digestive enzymes to break the flakes down. They also don't drink water. Instead, they absorb moisture directly through their bodies from the humid air generated by our breath and sweat. This mattress cross-section shows a three-dimensional ecosystem divided into upper, middle, and bottom layers. Looking at the black bars in the following graph, the mite population doesn't just stay on the surface. A significant portion of them migrate, thriving deep within the protective middle layers. The creatures we often fear are not attacking us in the dark. They are simply mining the deep geological layers of our biological waste. While this invisible food web is harmless to the vast majority of people, it becomes a clinical problem for those with highly sensitive immune systems. The physical triggers of a dust allergy are not the bugs themselves. It is the inhalation of fungal spores, along with the leftover digestive enzymes packaged inside dust mite waste, that causes airway inflammation and asthma. Simply having mites in a bed does not guarantee you will get sick. The severity of an allergic reaction is directly tied to the total population load established inside the mattress. To control the population, you have to manipulate the climate. Dropping bedroom humidity below 50% physically starves the mites of the atmospheric water vapor they require to live. You can also destroy the surface biome with thermal shock. Washing bedding weekly in water exceeding 120 degrees Fahrenheit is lethal to established colonies. Finally, allergen-proof encasements act as a physical blockade. They sever the supply chain, preventing fresh skin cells from ever reaching the scavengers in the deep interior. We will never completely eliminate nature from our homes. But by recognizing our role as the climate engineers of our beds, we can negotiate a much healthier peace with our microscopic roommates.